Alright, time for another DraftPhysics.com video presentation. So, comments and physics, Michael's physics, whatever, physics, Michael, something like that. So him and others keep repeating this point that somehow I have flatly denied, okay, his experimental data. And so I'm going to do this again and point out how, no, it's not a flat denial. I'm explaining why what you're saying is nonsense and what you showed in your experiment is garbage. And it's because you haven't paid any attention to your own videos. You haven't watched your own videos where you're talking about systematic errors and random errors, and you're not really paying that much attention. And through your advocacy, you're advocating that people do these kind of sloppy, at-home, DIY bullshit experiments. And all of that's crap. And the real subject is that in 350 years, since you've had this notion of energy, that simple things like showing it takes 4 times the fuel to go twice as fast, you haven't managed to do it. In 300 years, you haven't managed to record in any way this event. And that's preposterous. Just as it's preposterous that NASA hasn't done the Eddington experiment from space with 400 times better resolution. It's insensible that that's what your science is doing in terms of its investigating or its proving or its testing. It's so uninterested in testing that it never did any of these simple tests. That's the subject. How credible can the science be if it doesn't test its fundamental arguments at all? I mean, at all. No tests. Since 1720, conventional physics hasn't done a single test to prove kinetic energy is a real formula that actually gets right answers. Not a single test. All right, anyway, a credible test. So I have notes here, so I might as well show my notes and then make them clearer. So in thinking about it, yeah, I can do that. You probably can't see all of this, but I was just thinking about, look, it's 1 mile an hour, right? I get something going 1 mile an hour, I crash it into a scale, bang. 1 mile an hour, it weighs 100 pounds. I move it 1 mile an hour, crash into a scale, the scale shows 100 pounds. So 1 mile an hour is the velocity, okay? It's 1 centimeter fall in gravity. That'll get you, okay, an extra version of your weight as an impulse. So you'll weigh your weight twice. So you just extract your weight from your motion weight, and you'll weigh the 100 also. And it just works out this way. You want to weigh 200 pounds, you go 2 miles an hour. You want 4 miles an hour, 400 pounds. 8 miles an hour, 800 pounds. And that's how it works. And it ends up at this 4.9 meters that you travel in gravity. You'll be going 9.8 meters a second. Your velocity will be 22 miles an hour. That's what it converts into. And you'll weigh 2,200 pounds if you start off weighing 100 pounds. That's the reality, and this is what you get per second in gravity, is that kind of increase in your weight. You fall 2 seconds, it's 4,400 pounds. All right. And then this was just charting the fact that, I mean, do we really have to make this argument? If I take the same one little p and I move it at a velocity, and then I take the p and I double the size of the p, and then swing it into the same distance, and I swing it into an object, and then I triple the size. We know the spring incrementally weighs these things correctly. And then if I do the inverse and I keep the size the same and I just increase the velocity, twice the velocity, 3 times the velocity, 4 times the velocity, I'm going to get this same incremental increase in the spring's compression. That's what springs work. Scales work. Oh, shit. They do in fact measure, okay. They measure, okay, the scale measures your momentum. That's what they do. They're measuring your momentum. They're measuring your energy. They're energy detectors and energy scales. You know. All right, and so this is his experiment, so I guess we'll go over that. But you know, all you're getting is the momentum back. You're getting it in a different direction. So this conservation of momentum, I've never argued for anything else, nor have I argued that momentum is anything other than a vector. So people are just keep lying and putting words in my mouth I never spoke, saying I changed my opinion when I've never ever drawn momentum or energy or velocity as anything other than an arrow in a direction. All right. So in the experiment that Michael did, he put two things on a spring that is expanding. So instead of compressing the spring with these entities, he's instead expanding them. Okay, so he compresses the spring the same amount, and he gets as answers, okay, he puts light weights on, he gets a momentum number of, say, 200, you know, if you count both directions. And if you put twice as much mass on, he gets an answer of 400. So somehow he gets the same spring compression to create two different momentums, total momentums. And the rational argument in opposition would be to point out that how can that really be possible? How can something that measures weight, a spring, how can you put a different weight on it and get the same answer? How could two things hitting the spring, a 50-mile-an-hour crash versus a 100-mile-an-hour crash? He's basically saying that a 50-mile-an-hour crash gets you the same answer on the spring. The spring does the same compressing as the 100-mile-an-hour crash. It can't make any sense to anybody rational, in my opinion. Can't possibly be correct that this actually physically happens in the physical universe. I mean, this experiment has to be garbage. I mean, whether it's garbage on purpose or why it's garbage, but it's clearly garbage for him to argue that the same spring compression created twice as much momentum in one case as in the other case. Come on. How could that possibly be part of reality? So I'll draw that again in bigger detail. Play a little clip from the video. Obviously you can't see the experiment very well, but I'll just play this clip. So he's just loaded the carts with more than twice the weight. So the carts now have more than twice the weight.
Close to each other as I can get them. Say okay. And let's take some new data.
So he's just hitting a spring between them. He's going to release a spring. Now obviously the spring has plastic parts. Who knows whether these springs are going to hit or whether they're going to push. So these are a real physics it's a real thing. Throwing an object at another object, letting it bounce. Well, that's different than having a spring and allowing it to push. Always having contact. Steady contact versus banging contact. You'll get different answers. So that's one of those systematic errors that you have to try to avoid.
All
right, so his claimed data collection now is that he's gotten twice the total momentum. The carts now have more momentum. So this is the creating momentum experiment. Now in the same set of experiments he did the Lewin experiment where he hits the one mass cart into the two mass cart, and the two mass cart leaves in that direction, that direction with 1/3 more momentum, free momentum. And he thinks that's a viable concept in the physical universe, that you can give things more momentum without having momentum to give. So somehow momentum doesn't make things have momentum. That this special kinetic energy does somehow. How they don't draw. They don't explain where this scalar energy does or how it does it. All right. So that's enough of that. So I'll draw this and I'll point out why it can't make any sense to me. Sorry, just no freaking way are you going to make this make sense. All right. That I can take a 100-pound football player going a certain velocity and he smashes into a dummy. and then I can take a 200 pounder and I can give him more velocity, not as much velocity as the 100 pound, but a lot. So he has twice the momentum, and he hits the spring and he compresses it exactly the same amount. I mean, how could I possibly believe something with more momentum doesn't compress a spring more? I mean, how can anybody believe that? Frankly, I don't see how you can believe that. So I will diagram it once again. Alright, so he takes the one mass and a one mass spring, and they will leave with a velocity. Okay, let's just say it's 2 velocities so we can make it semi-simple. Okay, so they both go off at 2 velocity. You can understand that these are 2 creations of energy in the universe. They're semi-independent in the sense that they're both real capacities to do work in the universe. This can do work, this can do work. Alright, so it's real stuff that's been created. It does the same exact spring compression with, say 3 times the mass. Just about. But anyway. And we're to believe that these velocities is something like, well, I should just make it the 2, since that'll make it 50. You'll understand the concept better. So these are 2 masses, and somehow they're going to have 1/3 more velocity, but it's going to be more than that actually in his experiment. So their velocity will be 1 point something, 1.5. Alright, so they will produce more momentum. So this experiment, so this one, say, let's produced 100 in momentum, and this produced 100 in momentum. His experiment, he's going to create 200 here and 200 here. So obviously we have a total of 200 momentums capable of hitting things in the universe, and we have 400 here from the same exact spring compression. Now the simple test would be, well, if I threw these things into a spring, I could have absolutely no realistic ability to believe that this thing with more mass, twice the mass, okay, that with twice the mass and 1.5 the velocity, that somehow this would compress the spring the same amount. That something with more momentum compresses the spring the same amount as something with half as much momentum. That I could do a 100-mile-an-hour car crash, okay, into another 100-mile-an-hour car crash, and that somehow I'm going to compress the spring exactly the same amount as if I had 50 and 50. That somehow that would be the same crash, that the spring would compress the same amount. Well, whether I increase the mass or increase the velocity, right, same difference. I'm increasing the momentum, and I would expect the spring to show that increase. If I increase either one of them, I have to compress the spring more. I cannot possibly compress the spring the same. The spring is measuring weight. This can't weigh. This cannot possibly weigh the same as this. It's not possible. All right, so that's why I think there's something wrong. Okay, there's something wrong with your data collection. You've made an error in the experiment, in conducting the experiment, because it is absolutely ludicrous to get different momentums from the same spring compression, because the spring compression is weight, and weight produces momentum. It's just a fact. Pressure produces it. So let's see if there's just no way to say it any other way than, do you realistically think if I reverse his experiment and I have 3,000 momentums, in his case 3,000 momentums coming in, and in the other case I have 1,000, and somehow it's possible that I'm going to compress the spring exactly the same amount? I mean, on its face, it can't be the truth. Can't possibly. Scales wouldn't work if this was a real thing. Alright, so now we'll migrate to comments, I guess. I will pause and think if there's any other points I really need to make today. Alright, since they'll come up in some other videos, I might as well make some of these points over again. So in some of the comments, there's been some conversation. It appears that Piro is actually now conceding, okay, that the faster you go across a scale, the less weight the scale will absorb. And the simple argument is that in rolling friction, that's exactly what's happening, in the sense that the illusion, okay, and it's just an illusion. It's one of those facts that's just not exactly, what it looks like. So platypus duck kind of thing. You have to look a little deeper, or you're going to get a wrong answer. All right. So I've done this many times, and we'll do it one more time, okay? Because that's what you have to do with you people, because you won't really address this subject. All right. So I roll something at twice the velocity. Okay. Oops. So it's twice the velocity here as it is going to be here. This is one velocity. All right. And the simple fact is the thing that goes twice the velocity will go 4 times the distance. Now, the argument is what is this experiment doing? Well, unlock, if I threw these things off a cliff, right? So I have a cliff and I throw them off the cliff doing the same experiment. All right, then I'm going to get a result by the laws of physics, okay, where one of them will go this distance and the one going twice as fast will just go twice the distance. And that's all you'll get, twice the distance. Because you're not taking the energy out of the objects, they're retaining all of their energy. This motion is being retained with the tiny amount of air resistance against it, and this motion by gravity is being retained by the fact that gravity is gravity and there's a little bit of air resistance, but basically these two things are not being taken away from the object. So if I could do it in space, they would just fly forever, right? And forever, one of them would always be twice as far ahead of the other one. Forever it would be 50-50. The one going twice as fast would get twice as far as the one going one velocity. So in these experiments we understand, okay, yeah, nothing special because we're not extracting their energy. So in this case, we are going to extract their energy. We're going to measure it. Now, if we measured it in these cases with a generator, or we measured it with an impact, we said, what do they impact with? What do they compress a spring with? Okay, then we're doing a legitimate experiment. We're going to test it and see how much energy it has. Now, I would argue if we test it with a spring, the spring will show perfectly that this one weighs twice as much. It's just going to be that simple. It's going to be a 2 number again. So in this case, we are extracting its energy. Now, Piro might agree that's what happens here. The energy is being extracted as it travels. And the simple truth is the extraction here is a lot more intense. The extraction here is more intense because the object is moving slower, so it's being exposed to more gravity. This gravity is a time-dependent force. It's raining, okay, and this gets very little wet here because you're going very fast, so you only get the same amount of water. If it was rain, the same water hits you here, same water that hits you here. You get just as wet here as you got through this whole path here. And that analogy, that metaphor, perfectly correlates to this actual fact that you're pushed into the ground less the faster you go, because there's less time gravity per foot can push you into the ground. There's less pressure. There's the same pressure here as there is pressure here. This is in fact where you go half your speed. So this section is in fact a duplicate of this entire experiment here. You'll reach one velocity 3/4 down the track, and you'll be duplicating. These two things will be exactly the same event, and this event, okay, will also be exactly the same in the sense that you've got the same amount of force into the ground. So the test is you have to pay attention to details and recognize that yes, this is just an illusion, this extra distance. That in fact, if this is the truth and this is sort of a lie. It's not telling you the truth because you can't see the fact that here there was a lot less vibration of the ground. The ground absorbed less energy per foot, and it absorbed a lot more energy per foot here. 3 times more energy per foot here. 3 times. And that's what Galileo figured out. 1, 3, 5, I mean, all of that crap. So 500 years ago, a guy figured all this out for you, and you've decided to say, screw that, because it doesn't fit with your, what you want to be the truth. But clearly this test is not a very good test. If you want to test how much energy these things have, then you find some way to create a mechanism where you take their energy, have them hit bowling pins, or have them hit some other thing, okay, that is not gravity dependent, because gravity is going to keep doing this to you. If you keep testing with a gravity mechanism, you're going to keep being stuck in this circumstance where as it starts to slow down, it will, in fact, more energy can be extracted. So test it with a spring, test it with some other mechanism. Alright, so we'll do another one again, and as I say, I'm going to keep repeating them until somebody else plays these actual arguments and explain how I made any errors here. I want them to explain how there's any errors in the reasoning or the logic I just provided in this example. Just show that I have somehow made a reasoning mistake, that I've logically missed something important. Show me what I missed. Show me that it's not half the speed here. So I probably should do the falling thing because it's exactly the same diagram. I mean, I could just turn this upside down and it'll show you what happens in gravity. It's 1, 3, 5, 7. You're going much faster through the gravity. As you go faster through the gravity's affecting you less per foot. That's why rockets can go into space with a limited amount of fuel, because they don't pay per foot. They pay per time. Now, somebody should just point out how that's wrong, how they don't pay per time in gravity. That when I'm lifting a weight, that it's not true that the slower I lift it, the more work I do. That it's not about time, and that the quicker I could lift it, theoretically, the quicker I can lift it into the gravity, the less gravity I have to fight, and the less work I'd actually have to do. And the object, in essence, gets lighter and lighter the quicker I can move it. Show how that is not physically consistent with everything we see in this mechanical physical universe. Show how I can't make that statement and be credible or sensible. Show that. Not all this other crap, not this crap-o-mathics that you're doing. Alright, so I have often metaphored, and I will do it again. I will analogize, okay, gravity to basically all you're really just saying is that a material object is a bucket, and the lighter object is a smaller bucket. So your mass will dictate how big your bucket is, and frankly, gravity is just a kind of rain. It could be a raining billiard balls. It could be raining anything. It's an amount of substance moving very fast, and you can collect it in your bucket. Okay, now when you're on Earth and just sitting there, you're collecting it. The spring says so. Okay, it's hitting your bucket. All right, it's pushing you into the Earth. You can measure how many of these little balls are hitting you. But the fact is, because you are ultimately connected to the Earth, all of the stuff falls out of your bucket and goes into the Earth. So the Earth feels the pressure, ultimately. The spring just creates a tiny little delay in how you get the pressure, but it all ends up going into the Earth. And if you're free falling, you just collect the balls, right? So you're collecting them as you fall. So obviously this one collects twice as much as this one in terms of force per unit of time. You know, it's a smaller bucket. It can't collect as many because it's a smaller bucket, right? So if this one has 6, then this one only has 3 or 4. So in the same unit of time, this one collects less than this one because it's twice as big. And when it hits the ground, it's going to have the same scenario in the sense it's going to weigh twice as much as this one is, because it's twice as big, and it's going to, all the little balls are going to fall into the earth, okay, first hitting the spring, of course, all right, and that's the fact of it. So the feather is tiny, it collects a tiny bit of balls of rain, drops. This one big mass collects lots of them, so when it hits the ground it has a lot more. But it's a 2-to-1 relationship, or 3-to-1, whatever the mass ratio is, the impact ratio will be. There's absolutely no difference between them and their weight. Okay, these things falling, okay, you can't change the fact that this one will weigh 1/2 of what this one weighs in terms of the impact weight. All right, just a fact, because they're going to fall at the same rate, gain the same velocity. Because the velocity they get is exactly proportional to how much they collect. So the more they collect, the faster they could go. But this one can't go faster because of its mass, right? It's got to collect it proportional to the mass. Alright, so the same scenario exists, right? So let's get rid of the different size and just use the same size. And so if I go 4 times higher, okay, just imagine that's 4 times higher. What am I really doing, right? This falls a certain distance in a certain amount of time, all right? And this one's going to fall, okay, 4 times the distance. And that just means, well, what's it really falling? All right, so the fact is that in the first second, it falls 4.9. All right, 4.9. But it's going 9.8. So in the next second, because it's going 9.8, right? It's going 9.8. It collected 4.9 in the 1 second. So that's what 1 second does. Second, it's going to get this, because it's going 9.8. It's going to get these 9.8 for free. So that's 2 4.9s. It's going to get that for free. So these two are a consequence of that first second. The first second gives you this for free. And then you go the one last quarter because you're in another second. So this is a second. The second gives you just 4.9. Okay, you got this, all of this, from the first 4.9. So the 3, okay, and the 1. And that's all you get in the second, is this one little bit. This you got from this first bit. And now you're going 19, so imagine it's much bigger, 1, 3, 5, 7 is the ratio. Alright, so but you're only in the gravity 2 seconds. So obviously as the raindrops are coming down, you're just collecting them. Okay, and the fact is you're moving faster and faster, so the final 3/4 of the voyage, okay, you'll be going very fast. In the first part of the voyage you're going 4.9. Here you're going much faster, and ultimately 19. Okay, when you're finished, 19.6. So you're going a lot faster. And you're going faster means you're just standing in the rain, essentially. The rain comes down really, really fast, so you can't change the rate at which the rain's falling into your bucket. But you're going to be in it longer. The fact is you're in it longer here. You're in it as long here as you are in this entire part here. So in this part here, you're only going to collect the same number of raindrops that you collected in this 4.9. And the same has to do with lifting off. So again, it's just an illusion. 4 times the distance doesn't mean anything, because it's twice the velocity, it's twice the time, and it's going to be twice the weight when you hit the ground. Those are the numbers that matter. Alright, now that wasn't perfectly articulate, but again, no mistakes in my opinion. No glaring error was spoken. So demonstrate where it's unreasonable for me to pay attention to all these 2's, okay, and for me to say the 4 is an illusion, because I can know when I'm going really fast I'm collecting less gravity. Alright, so last argument on that subject anyway, we'll just do quickly. Because I've drawn it so many times. So again, make the argument. We have a gravitational body. I'm going to take a certain place in space and say this is the distance we're going to go. Okay, their physics says it's per foot. My physics, okay, Newton, Galileo, and Descartes' physics says no, it's about the speed. So how fast I go across this distance will completely change how much the gravity will affect me. So the slower I go, the more likely it is I crash into the planet. the faster I go, the less, I mean, I'm almost not even bent. Okay, so the faster I go, gravity's just like a little paint sprayer. It's a little raindrops. The less wet I get. The faster I go from here to here, the less wet I get. The less work I have to do against gravity. So if you're thinking of yourself turning against the gravity pulling you this way, you have to do so much less work turning against the gravity the faster you go across this distance. Proving gravity is a time-dependent force. It is not a distance-dependent force. It's all about how long you are collecting the force. And obviously if you hit another object, or I tie a string to you and pull a cart, well, then you're not going to free fall. Then this is going to absorb the gravitational energy, and you're going to be in the gravity longer, but you're also doing more work. You're moving another object. So that will be proportional also. Alright. So that might be enough. We'll see if I have anything else I want to throw in this video. Alright, so now to some comments. I'll do the less snarky ones first, I guess. Anyway, so Piro chimes in. Short version. Gary has convinced me that saying conservation of momentum is a thing. Okay, with all the elastic etc. caveats is misleading. So the irony is, obviously I'm saying conservation of momentum is the real thing, but he's conceding the argument that if they're going to argue for kinetic energy, they really do have to destroy momentum. You can't conserve both. So I should point out that that's what this video says right in its description. Okay, we also test the properties of elastic collisions and show that both the total momentum and total kinetic energy are conserved. Now the simple argument is that's impossible. You cannot conserve both when you're exchanging energy between different masses. It's not possible to conserve both. It's a ludicrous statement on its face. And this has always been the real argument here, is these are not compatible notions. You cannot believe in momentum and believe in kinetic energy, because they theoretically say the universe is doing two different things. They have different assignment of the reality. In one case, something has the same capacity to do something, in the other case it has a different. It's the difference between the number 1 and the number 2. They get different answers to the same question, and that's not reasonable. Alright. So Mindless Marbles chimes in. Piro, do you realize Gary does not actually support or think that conservation of momentum holds? So this is just another preposterous lie. I mean, it's an insane lie. My theory for 10 fucking years, for 20 years, for 40 years has been momentum is the real thing. So it's a ludicrous statement for somebody to make. I'm demanding it. I'm saying Descartes was perfectly correct to imply that God poked the universe and the energy is just moving from one object to another object through the rules of momentum. Through the rules of you cannot destroy the mass and you cannot destroy the velocity in the universe. You just can't do it. Those things, the energy, the movement, and the matter are indestructible. And the motion just moves from one place to another place. And that's all it ever does. And that's all I've ever said, this lying sack of shit, to say that crap. He uses the name conservation of momentum. I state it, I draw it, in every respect I believe it. But then means something completely different than what standard physics means. Well, yeah, I guess so. I believe in MV. Okay, I don't know what standard, when you hear the word momentum, I guess apparently you don't understand that it's masses moving velocities. And that you can have big M and little v, and you can have big V and little m. And those things are equal by conservation of momentum. So I guess I don't understand you. That's right. I don't understand. It's mass and velocity. and all you can do is move the velocity to different masses. That's all you can do. This is part of his many rhetorical tricks. So there's no rhetorical trick. There's no, I mean, it's just such a lie to make everything so much more confusing. What's confusing? I'm the one defending the simple theory. You're the one defending the complicated one. Okay, when he says the word momentum, he means absolute value of momentum. Why, yeah, I mean real momentum. I mean MV, which isn't what anyone else is using the word to mean. So anyone else, he's claiming all of you don't understand that momentum is just mass and velocity, and that the two players are equal, and that if I, hit a large mass going a slow velocity, that I can convert that theoretically into a big velocity in a small mass, or vice versa. That this can be done in the universe. That lots of little things can leave with your momentum, like heat. Also, there's no sense in which you could meaningfully say conservation of momentum is a mathematical artifact. It's an artifact in the sense that you've made it incompatible with your reality. You can't keep both theories, so you have to choose one of them because they're in direct contradiction to each other. They don't examine or define the universe the same way. They describe it completely differently. You cannot have two completely different descriptions of the same reality and call yourself rational. Alright, at least any more than any other consequence of Newtonian mechanics is a mathematical artifact. So again, he's claiming that Newtonian mechanics has gives any ground to the living force, or Leibnizian mechanics. Newtonian mechanics is not Leibnizian mechanics. So again, he won't even concede that simple argument, that the two are in conflict. The point is that there are simple principles that have physical implications. So that's just baby talk there. That doesn't say anything. Because obviously all these rules are conditional. As found out by the Newton's third law, in the sense that, you can make the argument that going this way is different than going that way. Or you can make the argument that no, it's the same thing. That's the conservation. Going that way is conservation. You don't need an equal and opposite reaction. You just need an action causes an action. It doesn't have to be opposite. Alright. You give away your money, you have less money. I mean, that's the simple argument. There's no opposing force that makes you poor when you give your money away. There's just your one action of giving your money away. The one action is all you need. You don't need a reaction. Okay, so Piro, side comment here. The value in all this, from my point of view, is that when explaining or discussing physics with someone, often when you start making an informed explanation, the other person will relent when they start to get confused. So he's saying that people will weasel out of the conversation, because they'll just give up. Because they don't want to do your math. They don't want to do your bullshit and have to argue through all of they don't want to find the defect, because you've hidden the defect in so many clouds and so many trees and so many watermelons, and they're supposed to find the little defect in the picture, and they're saying, oh fuck you, there's too many things here where it could be hiding, I don't want to be bothered. They give up because you decide to up the rhetoric game by just complexifying it, levels of complexity, and say, I'm just going to make it so complicated you can't argue. People don't want to look too dumb and start being, okay, sure, instead of continue to ask what is confusing them. I personally love to keep asking when I'm confused. No, you love to insult people. That's all you do. And I'm not worried some people think that's stupid, but most people will relent before getting too deep. Alright, so now he does his punchline to that statement. DraftScience has zero worry about looking stupid. It's not true. I mean, I don't like making mistakes, frankly, but I haven't made mistakes is the whole argument here. For 2 solid years, I've been drawing these same images on this board, levers and springs, and requesting that one of you believers, one of you people who thinks I'm going to look stupid, I'm asking you to get it over with and just draw it and show me where I made a mistake, where I don't understand. You won't do it, you pussies. Okay. Albeit for bad reason. Okay, so somehow it's a bad reason that I'm a devotee to my definition of the truth, that I'm doing it for a bad reason, that everything I argue for my existence somehow doesn't have any integrity in his opinion, because I'm advocating for these principles and these ideals for malicious or bad reasons. I'm a vegetarian for the wrong reasons, somehow. It's not because I recognize that I don't really have a right to torture things for a meal, that my gratification of my hunger shouldn't come at something else's expense. Ooh, gee, what an unreasonable belief. Anyway, he thinks he's always right. I think, until I'm demonstrated to be wrong, that I have every good reason to believe that I do pretty good lawyering, that I'm a pretty good advocate for defending things that I think need defending. And there's no evidence I'm bad at it, let's just say. I win a lot of arguments. However, this quality of draft science allows us to delve deeper into the subject. So he's making an excuse, oh yes, well, we can use the retard, the retarded baby to hold the door open. It has this extra special, don't think it's bad if you have an autistic kid, because hell, you can use it to hold the door open. Okay, and if someone, and sometimes he comes up with something that I have to think, wait, how can I explain this? Yes, exactly. And know what you should do? You should be at least honest about that and say you don't have any counter arguments for what I just did on the board there for a half an hour. I just detailed a whole bunch of facts. Now, why don't you explain how any of those facts are unreasonable and belong in this silly category? And or wait, do I understand how to explain this to even myself? So exactly. So you should be able to do that, though, right? And so the fact that you have some dissonance and you're saying, well, these are reasonably good points. Why didn't the Mythbusters? I mean, why didn't, when they crash a car at 50 miles an hour and then they crash a car at 100 miles an hour, why didn't the car show any indication of the extra energy? I mean, there's twice as much energy. I mean, shouldn't there be some 4 times more energy? Shouldn't there be some indication of that? And instead, we just have twice as much. It's just boring. Yeah, it should give you some dissonance. And then you should say, well, maybe I have to rethink this crap. And then it'd be really easy to see where the crap is. The 1/2 and the square. The per second. I mean, how many times do I have to mock it? Why would I say per second? Why would I say that? I'm going to drive down the road at 60 miles per hour. Why would I add that extra per hour on there? Why would I do that? All right. So 1, Ft equals mv. So force times time. So anyway, this is only true in gravity explicitly, but obviously in other circumstances where your velocity is going to be linear, okay, it's going to change linearly, all right, then it can still be used, based on time and distance. But I'm just saying you have to be a little bit careful. The force times time doesn't say it all. It says it all in gravity. That's the important part. Never thought about that before debating this. Interesting companion to FD. So there's actually no companion. FD was always a bad logic, bad reasoning. I mean, it should never have been about distance, because we know distance is flawed. It's not a good indicator. It's exactly what you want to do. If you want to take the wrong road, you take distance. Distance is only circumstantially consistent. And all I do is change the circumstance, and distance loses all connection to the truth. All right, so there'd be no companion. You don't need any companion. FT works, so MV works, so just forget about this FD stuff. You don't need it, because the FT, the MV works. What is the confusion about levers and velocity? I mean, clearly the confusion is that you're saying something crazy, frankly, that the lever doesn't conserve the motion, that the lever doesn't conserve the momentum, doesn't conserve the weight. It is collision. It's the collision is pushing concept, which, frankly, it's weight. Weight is pushing. So it's the whole thing is consistent with pushing. And the fact that really you have to understand the angular qualities at play. So there's no angular momentum issue. So let's just understand that if I have a wheel and I turn it, okay, so I have gears, and I put the weight here, okay, that's heavy, and I put a light weight out here, the angular momentum is exactly the same. It doesn't change how much energy it takes to move this the larger distance than it takes to move this the shorter distance. So angular momentum is not going to be an issue, because it's just as linear as this distance. It's just as consistent. Whether you're using a gear or using a lever, it's the same mechanics. And there's no angular momentum issue, because they're both perfectly symmetrical. Alright. You have to understand the angular qualities at play, or pretend everything really is instantaneous, even if it's not instantaneous. So Piero is making up some sort of crap that this weighs something and this doesn't apply a counter pressure all the time. That somehow there's some huge delay and this doesn't know that this is pushing down, and that somehow it's complicated. When no, that's exactly what the lever is showing, is that it's not really complicated. Now, the fact that things overshoot is just a consequence of the fact that you end up with that extra momentum and you have to get rid of it. And it takes time to get rid of it. Anyway, number 3, conservation of momentum is the thing that's a mathematical artifact. Conservation of momentum is the thing that is a mathematical artifact. So I'm just arguing that clearly I don't agree with that. And clearly the mathematical crapafact is mv squared, the living force, the fake, stupid notion of reality that has nothing to do with Newtonian mechanics. That's the piece of crap. Newton was right, Galileo was right, Descartes was right. Quantity of motion, momentum, is energy. It works. It gets right answers. And this appendage you've stuck to, physics, this piece of garbage, this gremlin, is of no value. Mathematical artifact that happens when collisions can be modeled as if everything collides on a spring between two objects. Clearly, you don't model it as a spring. You model it as either absorption or reflection. The spring provides the opportunity for reflections. That's all, in a sense. Storage and then release. Okay. A delayed reflection, if you want to call it that. Sort of like the solar energy hitting the plants 300 million years ago and being stored in the ground. And we release it, and we're really releasing the same solar energy. We're just allowing it now to reflect. We delayed the reflection by millions of years. That's all. The energy goes into the spring and then comes back out of the spring. Right, the energy, which is the weight, which clearly correlates to momentum. Momentum is weight. That's what the 1 mile an hour thing proves. Momentum is weight. I give this thing a momentum, 1 mile an hour, I will weigh its mass. So 1 mile an hour impact weighs its mass, its momentum. Springs weigh momentum. The energy get back out. Mathematically, you have conservation of momentum but it's really just conservation of energy. So this is just circular reasoning. So obviously conservation of energy, in his opinion, is 1/2 mv squared. You can't conserve both. Again, every single time you transfer from a heavy object to a light object, or a light object to a heavy object, you cannot possibly conserve both of these quantities. When the energy goes back into causing motion, so it's already in motion. The spring, the whole time the spring's compressed, if I lock the spring is still pushing. Some kind of metal or some sort of object has to take it could be a very intense pressure. The pressure has to be absorbed by something because it's still pushing. It's still actively saying, I'm energy, I'm energy, I'm energy. I have momentum in me. And you have to suppress that momentum and keep it in a container. Just like a high pressure vessel is not inactive. It's not doing nothing, right? I mean, the hydrogen tank on the space shuttle isn't doing nothing. It's not just passively saying, what a lovely day. No, the metal is hugely stressed. Everything is freaking panicking a bit. All right. Motion is new, actually not converted. I.e., motion is new. So that's the joke, right? So I shouldn't even have to have that conversation with any imbeciles about anything called new motion. When energy goes back into causing motion, i.e., motion is new, actually not conserved. Oh, he just means new in the sense that it's a new photon or something. Like the photon hits the surface and it shoots out a new photon. The energy was absorbed by a system, and then the system just threw some other thing that looks the same. You know, you have a duck factory. Somebody throws a duck into your factory, and you just throw any old duck back out. You know, yeah, it's a new duck, but it's really the same thing. It's a duck. Anyway, the idea for that objects are lighter. Okay, so that's not really the way to say it, right? Is something I've encountered before, but not something I've ever thought I had to be argued. So he somehow thinks, okay, that friction is linear, because it's one of the experiments you use to prove your stupid kinetic energy theory. But you already also knew that no, friction isn't linear because I'm putting less pressure on the ground and therefore knocking down fewer pins. I'm not hitting the bowling pins. My ball is rolling and it's not hitting the pins as much when I'm going faster. And then when I start to go slower, I sink into the pins and I knock down more pins. I mean, any idiot could figure out that, well, you're losing more energy when you're going slower. I merely corrected people. So isn't that funny? So he's conceded. He's saying that he, for years, understood that the faster I go across the scale, the less I weigh. And even though he'll endorse arguments where somebody uses rolling friction as an argument for kinetic energy. So even though he knows that's bogus because it's not linear, the faster you're going, the less energy you're losing, the less energy you're putting into the ground. He's going to play this game. But I have better explanations now. My cousin recently said this out of the blue in a conversation about driving trucks on frozen lakes. Yes, you have to drive fast on a frozen lake, or you'll break the ice. Yeah, that's the idea, etc. I don't know what that means. Also, Gary is right about one thing. Oh, it's just so silly. He says all of QM and relativity arguments rely on energy being in units of FD. No, more importantly, they're in units of preposterous free energy, in the sense that you're saying the same momentum in lighter objects means somehow I have more energy. So you are creating a bunch of fake notions of energy in the universe every time you go from a big thing to a small thing. Every time physics mechanically changes a big thing into small, discrete energy, by their theory, they end up creating preposterous amounts of free energy, new energy. Alright, i.e. on KE. That's how he arrived at debunking it. Well, it's really not. I arrived at this argument because in an argument with Hothliday said the magic words. He said something like, Well, that 1/2 mv squared theory, formula doesn't make perfect rational sense or something. He made some sort of argument implying that the kinetic energy formula didn't make a whole lot of mathematical sense. Maybe he was talking about per second per second. And that made me think about it and say, what? Oh, they don't believe in momentum. I didn't realize you didn't believe in momentum, that you thought there was some other kind of energy. So every time I saw energy in a system, I thought you were talking about its momentum. And I realized, oh, I have to look into this. They actually think there's some other form of energy? So I had no idea there was any kinetic energy theory. All right. And then I found out, oh, you don't think energy is momentum. Oh, fuck. I didn't realize you were insane. Okay. By debunking QAM and GRSR. All I'm pointing out is the obvious, that all of those wacky theories with all that wacky crap in it was all part of the mistake, okay, Einstein's mistake, frankly, of buying into 1/2 mv squared as being energy. That's an interesting thread to notice. Well, I don't think you're noticing credibly or correctly, but whatever, fine. Alright, now he's at a point where he realizes, so this is more bullshit, that I've realized something or changed anything dramatically, just more lies, that I'm, in a panic to revise everything. No, the arguments I've made 10 years ago about how the universe works are still consistent and the same. And it's just a lie. Alright, now he's at a point where he realizes that FD is work, is energy. No, I don't think there's anything about FD that is a good idea. And the only time it's going to get right answers are like the dead clock, once a day. Having v squared in the formula is related to acceleration having s squared. So there's no realizing this. I don't know what he's talking about here, but yes, it's just you saying per second, where all this crap comes from. That there's any reason to do that. And again, you're multiplying. I mean, it's probably worth drawing, damn it. I mean, it's so nonsensical what you're doing to the math, and it's so simple. I mean, that I really shouldn't even have to argue it. It's just so simple. I mean, your error is so glaringly simple. The formula is 9.8 meters per second. Now, everybody should be able to agree. We all should be able to agree that formula means 1 second. It doesn't mean any number of seconds. It's a ratio. 9.8. Okay. This marker was much better a little while ago. Well, we'll keep trying. It's 9.8 over 1 second. Okay. It's a quantity per, it's a unit per unit. Okay. You're getting these meters per second. All right, and you can play a game that these are seconds that that somehow are the same second. No, it's 9.8 per 1 unit of time. And what you're going to multiply at times is how many times did the 1 unit have. So it's 4 units of 1 second. There's no squaring here because these aren't the same number. 1 and 4 aren't the same number. You don't square them. And if you square a 1, that's not going to get you anywhere. But it's just kind of silly to say that these are connected because this is a ratio, and you don't want to pay attention to the fact that this is a ratio that has to stay the same. You can't make this number different and keep this number. If you make it 2 seconds, then this is 19.6, and if you make it a half second, it's 4.9. So don't pretend you can change this 1 into anything else. You can't. It's per 1 second. And you just sit there and multiply it times, well, how many seconds did it fall? 2. Okay, well then it's 19.6. You just multiply 2 times 9.8. So what you've done to this simple relationship, this is so simple, and you've perverted it into nonsense. It's 1 unit of 9.8 per 1 unit of whatever time you want to say, right? But I mean, seconds is what the 9.8 is connected to, and if we make it minutes, then we have to change this number. Oh, come on. I shouldn't have to argue this. They just keep perverting the truth. Okay. V2 is a funny. Okay, so anyway, there's no realizing anything. I don't know what the fuck he's talking about. I didn't realize anything. I've always known you're stupid. So, it's not a new realization. He is now starting. See, look, he's doing it again. There's absolutely nothing changed in my rhetoric in these 2 years. So quit lying, you fuckers. And he is now starting to debunk the formula for acceleration. I'm saying the concept of acceleration is retarded in any sense beyond it's made out of velocity. You're just changing the velocity. You're not doing something magical that allows you to have some squared volume or something. There's nothing you're doing. You're just changing the velocity, which you have to admit is sort of fascinating. I don't understand what the fuck you're talking about. It's just such a pile of crap. I've been opposed the math from the very beginning. I pointed out from the very beginning it wasn't Newton's formula, and I pointed out how if you draw it how Newton drew it, you could understand that it's change in momentum over time. But it's only over time if you want to get the ratio. If you want to know how much per second. If you just want the net force, then it's just F equals change in momentum. I've been saying that for years. He's begun debunking acceleration by debunking unit analysis. So this is just their I don't know what you call that, secret code decoder ring kind of rhetoric. Unit analysis. There's no such thing. All right, and at the same time, mathematics itself. No, I'm arguing that this simple facts, that you can't square what are two different numbers. If I have two different numbers in a graph, and I'm going to say the area under the graph, and I'm going to pretend, okay, these are just multiplications. I can't multiply two different numbers and then say I'm going to have a shorthand for multiplying these two different numbers, and I'm going to square the number. You can't square the 3. You can't square the 1, theoretically. It's 1 times 3. That's not 1 squared, and that's not 3 squared. Alright. I.e. that dt over t, so he's doing more of his little math crap. Alright. He is correct that QM and relativity are based on the idea that energy has a unit. So that's a lie. It's obviously not very quantized. There's no consistency to the quantization. Clearly they can have this, different momentums create the same spring compression, which makes no sense at all. And the unit is kilogram meter second square, meter squared second squared, which is more gobbledygook. Okay, but somewhere down this rabbit hole, of course, you'd expect he'd go, oh, that's why time is squared. Why would I say that ever? Why would I think you can square time or you can square velocity? They're vectors. Time is a vector, forward, back. There's no squaring of time. Oh, that's why velocity squared is there. Why would I ever say something that's stupid? I think the simplest way to see where the squared units come from, so you think he's going to have any way to explain where squared units of time or velocity come from? No, I don't think so. From is understanding calculus. So now he's going to blame it on calculus. So let's understand. Newton invented calculus, frankly. It's a proven fact. He did it first. And he didn't see any of this crap. Okay. But of course, we're trying to convey an understanding that doesn't require calculus. So again, they're really just going by the fact that they think every time you multiply two numbers, even if the numbers are different numbers, right? The horizontal thing is not the same as the vertical thing. That I can just take any one of those numbers and decide to square it, and I've done the same thing. So 3 times 3, 4 times 4, that all makes sense. But 4 times 5 is not 4 squared, and it's not 5 squared. You can't do that. Note, that might be a mistake. Yeah, it is a mistake, frankly. It's probable that the geometric explanation of calculus is primary to the intuition here. I don't know what that, this is just gobbledygook. that distance is the area under the velocity curve, etc. So again, this obsession with thinking that distance has something to do with how much you paint gets on you, when no, it's all about how fast you move in front of the spray of paint, and the distance is incidental. After all, it's intuitive that areas are squared. It's intuitive that areas are squared. So this is another big mistake, right? Because my intuition says all areas are not squares, they're rectangles. You can't use square geometry. You can't use your square shortcut for a rectangle. And this area and it's clear the columns under the curve are all pure distance. So I don't even know what that even could possibly mean, whatever a pure distance is, in the case of velocity curve. So again, it keeps telling us that velocity is somehow a three-dimensional or two-dimensional object, when clearly it's a one-dimensional line. If in my retirement I start making dead simple physics explanations, so again he's saying dead simple, you know, when he's talking this jargon about squares of velocity. Yeah, velocity squares. Oh, damn. I think I will start there, or if I start making them again, I guess I should say, as I used to make that sort of video from time to time. Let's understand, I used to make videos all the time, and you know, the reason why he stopped making video, in my opinion, is because everybody thought he was an idiot. Yeah, some of the shit he would propose was just absolute nonsensical crap, and he didn't do any scrutiny, and he certainly didn't pay attention to any counter arguments. Hathaway couldn't stand conversation with Pirro, just found it so obnoxious because he would never stay on the subject. All right, bouncing education ideas against the brick wall. I don't even know what that means. May never break through the brick wall, but it actually a reasonable way to create better and better ideas to offer those people that are not brick walls. Well, I could make the counter concession that I had no idea I was going to have to argue with complete imbeciles, morons, children. And so it has, made me aware that, yeah, you have to start all the way back at the ABCs, and you have to work your way up to the big words like cow and bird and duck. And you have to probably have flashcards because you're fucking retards. And I didn't think I was talking to retards. I didn't think people were belligerently stupid. But that's what you all are. You're God botherers. You can't just explain and draw a picture of evolution and say, look how logical this is. Because you really can't do the connect the dots thing. You're too stupid. Alright, P.S. By the way, my background is that I have a philosophy degree, but studied math and physics for 2.5 and 3 years. So again, he took the mandatory physics courses. Okay, blah, 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 blah. Worked in an observatory, and so again, the fact that this scummy creep won't, he has been intimately connected with the manipulation of telescope data and its, compilation and applying algorithms and doing this, all that stuff he's been intimately, connected to, and he won't concede that it is damn fucking weird that NASA hasn't repeated the Eddington experiment. For 50 years we've been in space with the technology to do the experiment with 400 times better resolution, and you don't need to worry about the quality of your eclipse. And they've never repeated the experiment successfully. Well, they never repeated it at all from space. Never even tried it. We're supposed to believe they never even tried it. And he won't comment on that and admit, boy, that's almost impossible to believe. So not a scientist, but 20 years of scientific programming experience. So again, I already think your demonstrations are getting very valuable. So let's just understand his demonstration was that he showed a 400-pound guy running into a spring, okay, and a 200-pound guy with half the momentum, and he showed that they push the spring the same amount. Even though they have very different momentums, insanely different, okay, very different, the spring compressed exactly the same. That's a valuable experiment to see, of course. Getting very valuable for those that don't look at it with denial. So those who don't scrutinize it and say, how really is that possible? How could different momentums compress the spring exactly the same amount? How could different weights weigh the same? How can that happen? Except on a lever or some other mechanical device. How could I just put things on a spring and I have two things that don't weigh the same, but I put them on the spring and they weigh the same? How can that possibly happen? And probably even for those that do look with denial, that's more wishy-washy. Also, I'm not saying give up hope. So again, there's no hope here. He's just reciting from his Bible. He has done cliche, redundant, exactly the same tripe you hear from physicist after physicist after physicist. And now in his comment, right, he admits he was a teacher. He was or still is. And this is the danger, right? Danger, Will Robinson. The loonies are running the loony bin. Gary does learn things. Little details. Now, big concepts, already got it. Thank you very much. He's in pretty deep on this. I don't even know what that means, and beyond the fact that, oh yeah, I have to do all this research because it doesn't matter what you say to you people, you'll never be convinced. So it doesn't matter how much, if I could actually find Eddington taking the glass slide and going, whoops, I dropped it. Okay, I mean, if I had a videotape of him, destroying the evidence that didn't fit, with where he was trying to go. I accidentally lost that one, right? How much do I have to give, right? So in his journal, I read part of his journal. He points out he was hoping for 10,000 stars on the glass slide. He got 1,000. That is a gigantic fucking goddamn degrade in your fucking data. 10% of the data quality. And so as a reaction to that, he honestly said, I sure wouldn't stake my life on these results. And yet, when it was time to publish, right, all of that was gone. The public didn't hear that part. All they heard were Einstein proven right, New York headline, New York Times headline on an experiment where he got 10% of the data quality he was hoping for. 10%. And it was a 2 o'clock in the afternoon eclipse. It wasn't even really a great eclipse. So yeah, you have to go deeper and deeper. You have to go through all this crap and minutia to sit there and try to get you people to be a little bit honest. And you still won't do it. He's in pretty deep on this, but maybe the idea will tunnel through. So what idea is supposed to be tunneling through? This silly living force. I mean, I've given you the fucking history. It was completely defeated. Leibniz was buried as a loser, okay? As a kind of a despicable character, frankly. Nobody showed up to shed a tear. No one. Newton was buried as God, okay? And then, 40 years after their death, this crap was resurrected. 25 years after Newton's death anyway. This crappy theory was resurrected with silly clay experiments. And that's all. That's all this is. It's a story of how to do bad science. And since then, you've provided no credible evidence defending the theory. You just do your mathematical derivations, you do your fake predictions, and you don't produce anything real. And then when you attempt to produce something real, you do PhysicistMichael type experiments that can't possibly be credible. It can't be possible for two things to have different momentums and compress a spring the same amount. It's not possible. Anyway, brick wall, there is always some probability. Blah, 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 blah. So again, he's conceding some points here, so let's not, we're not going to celebrate, but I mean, it's just so funny that he's still defending the notion that somehow I'm going to lose this argument when in every way I'm winning the argument. Your crappy facade physics is falling down. There's no better way of testing whether you understand a topic than trying to explain it to someone else. I would agree. And all of this the fact is I have fixed things that were broken because people challenge things for the wrong reason, and then in defending what I was saying, I'm saying, oh yeah, but there is a catch. So it always helps to do. You never have enough time, right, to do the testing you'd want to do. You'd love to be able, before I say every sentence, I'd love to take 10 years to construct every sentence. But yeah, we can't do that. But it's nice now and then when you catch those errors, but it's also disturbing that you can make them in the first place. So part of that is irritating. Especially if they're asking good questions. I'm also a big fan of the Bertrand Russell, about occasionally hanging a question mark at the end of something you've long thought to be true, paraphrasing, or less poetically asking AITA every once in a while. I don't even know what that is. But whatever. It is challenging to keep all these plates spinning. So that's the complex part, is to make sure that each one of these things still fits, that every experiment is still consistent with the overriding theory and all of that stuff. So that's the tricky part, is being able to do your testing. This is the impulse momentum theorem. So that's fine. I love that word. I mean, and the impulse momentum theorem. It's really the same. Momentum is always just momentum. There's no such thing as impulse momentum versus some other kind of momentum, but whatever. And for my students, so he is a teacher, which is frightening, I use this as an example of how important it is to clearly keep track of what kinds of quantities you're talking about. So F net D equals change in KE, and F net delta T equals change in momentum. So again, I don't know how he could be a teacher and not realize that there's no possible way the two theories are compatible in any circumstance where you're transferring energy from like a big thing to a little thing, or transferring it from a little thing into a big thing. They never get coherent or consistent answers. Again, the bullet and the gun. Momentum says the two things are equal, essentially. Now I'd argue there is some unequal momentum. I think if they actually could measure this stuff correctly, they would find that the bullet is going a little faster momentum-wise than the gun. But anyway, equal momentums, and yet kinetic energy says there's 1,000 times more energy in the bullet. Clearly, these are not compatible theories of reality. Oh, I just can't believe he keeps defending it. Even if you have an infinitely rigid bar, so again, you don't need an infinitely rigid one. We're doing a simple experiment. We're saying the lever weighs 1/10 or 1/50th of the weights you're putting on it. So you have something steel, something rigid. You want it to weigh as little as possible so it doesn't interfere in any way with the experiment, the absorption of the energy, because you don't want to be wasting energy moving the lever. You want to see the energy move between the objects on the lever. So again, they're just using this minutia to imply that there's some variables in here that are screwing the lever up and it can't conserve the momentum. So the interaction is near instantaneous. Again, it doesn't matter how fast the interaction takes place. It really doesn't matter. I mean, it's a steel bar. Obviously, instantaneous, twice instantaneous, 3 times instantaneous. I mean, who cares? Oh, it was, a billionth of a second slower than instantaneous. No. You still need to understand. I mean, we're talking about the speed of sound in something, and we're talking about the speed of sound at maybe 2,000 miles an hour in the substance, and we're talking about a tiny distance. I mean, get real. Angular quantities, at least as the most direct way of calculating. See, so it's just about calculating. It's not about understanding. It's just calculating. All right, the outcome of the experiment. So if you understand it as just weights, you don't calculate anything. You just say, obviously, the thing weighs more. If I put something, a lighter mass, further out on the lever, and I push on the lever, the light thing will weigh more. It'll feel like it's just as heavy as the heavier thing put closer. So that's a fact. All right, that's not a calculation. It's an observable truism. The incoming mass hits one end of the bar, producing a torque in the bar. So again, all of that is in. The point is does it conserve it or not? So here's the simple proof that their theory is going to be crap, right? The simple proof is that if I put a 2 mass here and I put a 2 mass here, right? And now I lift this 2 mass up and I drop it. They know this 2 mass is going to conserve the momentum. I'm going to get a pretty good conservation. So if I drop 2 here, and I'll get a 2 here, and it'll leave with the same velocity, pretty much. The lever's pretty conservative. What are we saying? 95%? I don't know. But it's going to conserve the energy. And now they're playing some game is that when I drop the 2 mass here, but I have the 1 mass 2 units of distance out, that somehow the whole lever is going to break down and not work anymore. That it's not going to be conservational. Come on. It's a ridiculous statement. The lever doesn't know that the 9 pounds is really 4.5 pounds, twice the distance. No, it doesn't know that. The lever doesn't care. It's 9 pounds as far as it cares. Anyway, it hits one end of the bar, producing a torque in the bar, causing it to rotate and produce a torque on the other end. So we're talking about a bit of rotation that's so tiny. So if you have a meter long lever, this rotation crap isn't even going to be close to an issue. Note that, and again, it wouldn't matter anyway because gears rotate and they work perfectly. Gears are just a lever moving through rotational 360 degrees of rotational space. It's still the same lever dynamics. Note that since the bar rotational motion is changing, those torques don't in general cancel. So whatever that means. So again, he's trying to say there's factors here that aren't really factors. A long enough lever, you've taken rotation out of the equation. It's essentially a straight line, a big enough circle and it looks like a straight line, right? A more rigid bar would generally mean that we get a massive value of torque for a vanishing small time. So there's no extra torque, there's no vanishing amounts of time or any of this crap. There's merely going to be a deceleration, and all you're saying is if I match it to something else's acceleration, that is if I cut the mass in half and double the velocity, I will be able to convert the energy going in one side into action on the other side. But we'll still analyze the motion by looking at the rotational version, so that's his choice, to pretend that in the first place angular momentum would be any different in terms of the symmetries. Okay, the symmetry of the lever and the symmetry of a spinning lever is exactly the same. And the impulse momentum theorem, net torque time equals change in angular momentum. So he's implying like angular momentum doesn't follow exactly the same rules as linear momentum. That is, the same velocity momentum rules. You're just changing the velocity. I'd agree with this so number 3, interpretation. Both conservation of energy and momentum only occur when we're talking about a closed system. So he thinks you can conserve both if it's a closed system, which is still nonsense. Has nothing to do with whether the system is closed or open. Now, obviously, any experiment you're doing to measure energy has to in some way account for anything coming into the system. But he's saying something like the fulcrum is an opening. And I'd say, prove it. Okay. So when the objects collide, for conservation of momentum, it doesn't matter if we're talking about them colliding via spring, contact forces, elastic, magnetic, or gravitational forces, or anything. As long as there is external forces acting on our system, the total momentum of the whole system will be conserved. So again, he keeps saying you have to conserve momentum, but you can't do it if you're going to conserve kinetic energy. It's not possible in any of these experiments with levers or springs or hydraulics or any of this stuff. Similarly, for conservation of energy, we need to make sure that we've accounted for every source of both mechanical and non-mechanical energy. So again, he's saying you can put twice the momentum into a spring and it'll compress the same as if it was one momentum. That's what he did as an experiment. That was the outcome of his experiment, frankly. He says it's the same energy. It can't be. The energy it takes to deform an object, for instance. So more bullshit about deformation. None of that crap has anything to do with these experiments in order to accurately use it. These give different pieces of information and both are required to fully predict the motion in classical systems. So again, Newton could predict it. Archimedes, give me a lever long enough and a fulcrum upon to lay it, and I shall move the earth. I mean, this is thousands of year old logic that levers actually do work, okay, that they actually do conserve momentum. All right, along with conservation of angular momentum, so he throws it in again. And you can show that all these conservation laws can be identified as the consequence of symmetries, yes. So again, you're conceding it's a symmetry. The rotational momentum is symmetrical in our system. Neither's theorem. Oh, it's in nothers, nithers. Anyway, what a pile of crap anyway. Time invariance for energy and transitional invariance for momentum. So again, more just absolute crap. It has nothing to do with the subject. Okay, 4. Not sure what you're referring to with this one. So he didn't get the reference to the fact that you don't weigh as much if you run across a scale. This is a special relativity thing where the relativistic mass increases with speed, or some other claim? No, the claim is simply that friction caused by gravity pushing you into the ground, is not linear. That the faster you can run across the ground, the less you will impact the ground. I certainly wait to get things clarified with classical physics before diving into QM, and as I did a kind of a walk before you run thing. So no, it's kind of, you'll fall down, okay, after you fell down. I mean, you're just showing how to do it wrong, not how to do walking right. Thanks for the background info on yourself, kind words. I'm hoping these scientifically critical thinking videos, so again, it's just, he's basically just done a video teaching, okay, that 400 pounds weighs the same as 200 pounds. So I can put a 400-pound mass on a scale and it'll weigh the same amount as a 200-pounder. We'll get more into epistemology at some point, so I'd be happy to hear your response of someone more formally trained in philosophy. How silly. I mean, his philosophical training is, again, more mush. I mean, he's a Nietzschean, Kantian. It's this mixture of, it's just nihilism and baby talk. Ugh. So, let's see, White Henry, what a terrible name. 4 was the reference to D.S.'s claim, the faster you move an object weighs less, demonstrated by him by moving his hand quickly across a little scale. If you move fast, you're in the gravity less time, so your truck will weigh less and won't break through the ice. Yes, there you go. So they're conceding the argument in some respects that the argument is in fact valid, that you probably are losing less energy to the ground the faster you roll. So they're basically showing that, yes, the illusion of 4 times the distance is just that, an illusion. It isn't a real thing. You didn't do 4 times the actual work. You didn't heat the ground with 4 times the energy. And they're basically starting to concede that argument, and it's a big win for my side, frankly. Now, if I can just get them to understand that the same thing is true in gravity. Twice the time, twice the velocity, twice the weight. Yes, 4 times the distance. Distance doesn't matter. Time matters. If I can get them to concede that gravity is a time-dependent force, isn't this all over? Because these are the only reasons Leibniz believed in this stupid theory, was because of the 4 times the rolling distance and because of the 4 times the height in gravity. These are the only reasons he believed it. He wouldn't have believed it if those things were explained to him properly. I don't believe he would have believed it, let me put it that way. But let's understand, there was times in this guy's life, I mean, not just when he was a kid, where he thought silly things. Like you could take a pea and hit a giant boulder, and the pea and the boulder would both leave with the same velocity. I mean, the same velocity as the pea had when going in. I mean, he really didn't understand quantity of motion as a quantity of motion. I mean, he really wasn't a Descartesian, that's for sure. He pretty much hated Descartes. So, these are all little bits of important philosophical history. Things have to be seen for what they were, not what you pretend them to be. This theory was not good science. It was a mockery of good science. Alright, that's probably enough. I mean, it really is a long enough video. And I do have, as they say, other fish to fry. So I wanted to get to all these lying comments that are in here by Mindless Marbles. I mean, just lie after lie after lie after lie. It's just so disgusting that these weasels get away with this crap. But I'll save that for some other day, or I'll just let it slide for this time. But I'm just, the very fact that these critics of mine have to lie so aggressively to make their argument. A reasonable person, let's say you're a reasonable listener, you should be able to appreciate that. Why would they so aggressively lie about what he's saying if what he's saying is so easily demonstrated to be wrong? Why would they have to resort to these preposterous lies? Why would they have to say something like, well, he recently admitted, blah, 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 when he never did that? Why would they do that? So ask yourself that question, and then you'll realize, oh, it's because their argument is so weak. People only have to cheat when they don't have the goods. When they can't win honestly, that's when they have to win dishonestly. So you should appreciate these people for the bad sources they are. Alright, anyway, till the next time, and such and so forth and whatnot. I really don't want to have some kind of nasty conversation with Michael. But he's forcing that issue, in a sense. Because his whole attitude is so patronizing, so arrogant, so obnoxious. Alright. Till the next time, and such. I mean, for an argument to be made with no evidence, and to keep saying, just do our math, shut up and calculate. No. People shouldn't do that. They should talk about what reality allows. And your overt contradictions in your statements can't be just you can't just let it slide and say it's okay to contradict yourself. Well, forget that. That doesn't work. Alright. Till the next time and such.